Okay guys, so this video is going to demonstrate how we determine our takeoff headwind and crosswind components using this chart from Diamond. So every time that we go to calculate a distance for takeoff or a takeoff distance or landing distance, we're going to have to know the headwind component. And in order to determine that, we're going to have to follow these couple of steps. This is pretty simple, but we're going to practice it here. So let's assume we've got an airplane that's taking off and or landing runway 36, assuming that the top of the screen or top of the sheet of paper is north. So obviously our direction of travel is going to be along the runway. The winds, though, are not always aligned with the runway. So let's assume we got winds out of the northwest at 25 knots. Let's say the direction is 330 at 25 knots. So our surface winds are not right down the runway, but we always do want to take off into the wind. So in this case, runway 36 would be favored. We wouldn't want to take off the other direction because then we take off with a tailwind, which increases our takeoff distance. So we still want to take off runway 36 here, but what we need to determine is that wind, how much of that is a headwind, or you'll see me say headwind component, and also how much of that is a crosswind. And you'll see it written as XWC for a crosswind component. Using that chart, we can actually do this. So the first couple of things to take note of, obviously we have our wind data, direction and velocity. What is the direction of travel? Well, we're on runway 36, so we could assume that the airplane is going to travel 360. What we need to do first here is determine the angle between the wind direction and the runway. And just to visualize that, we need to know how many degrees is that. Well, we got 330 is the wind, runway is 360. That's going to be a 30-degree difference that we've got between the wind direction and the runway. So that's really important to know. So we got a 30-degree difference between the wind direction and the runway, and the winds are at 25 knots. With that information, we can now go to our chart to find out just how much of that 25 knots is a headwind, just how much of that is going to be a crosswind for us, because crosswind components, there are limits for that too. So we go to page 4 of our performance packet and we see this chart here. It does look a little bit confusing at first. I'll point out a couple of things here first. We're always going to start at the 0 point here inside of all this semicircles at 0. These circles at 10, at 20, and at 30 knots are wind velocity circles. So we're going to go out to one of those semicircles based on how strong the winds are. And these lines, you see 10 degrees, 20 degrees, 30 degrees. Those are going to be the difference between our runway direction and our wind direction. So in our case, our difference between our wind direction and our runway was 30 degrees. So we're going to use that 30-degree line. And we know also that the wind velocity was 25 knots. So starting always at the 0 here, let's find our 30-degree difference line. So that line is right here. And we're going to travel in that direction till we hit our velocity. Well, we said it was 25 knots. So there's 10 knots, there's 20 knots. We see 30 up here, so 25 knots, that point is right there on my circle. And we're now able to use the chart to determine total headwind component, which is on the left, and total crosswind component, which is on the bottom. So from that position, we can use these handy plotters that I'm going to provide. And we can put the plotter right on our spot and make it as straight as possible. We go to the left here to see our headwind component there. It's going to be about 21 to 22 knots. And if you look down at the bottom, our crosswind component is going to be about 14 knots for that example. Just a quick demonstration. You look over this, you do it a few times, should be pretty easy.